Hello, my dear Form 5 students. We are here to continue on our redox reaction lesson on the chapter redox reaction. Today we are going to do part 10 and teacher going to cover from page 127 to 130 in this lesson. Okay, so our subtopic of this lesson today is conversion on iron 2 ion to iron 3 ion, or conversion of iron 3 ion to iron 2 ion. Okay, so as all of us know, iron is actually a transition metal, so it has more than 2 oxidation numbers. Okay, and iron 2 ion and iron 3 ion respectively produce color. For instance, iron 2 ion is green. Okay, iron 3 ion is brown. Okay, so I hope all of you can remember this, because when we were doing on our chapter rusting as redox reaction, teacher have explained how to associate the color green and brown when iron is rusting. Okay, so let's continue on this video, which is teacher going to talk on conversion of 2, which is iron 2 ion to iron 3 ion, and iron 3 ion to iron 2 ion. So before that, we have to know few agents which are oxidizing agents or reducing agents which are popularly used in order to do the conversion of iron 2 to iron 3 or conversion to iron 3 to iron 2. Okay, so I want you all to remember that iron 2 to iron 3, when iron 2 ion is going to iron 3 ion, please remember that it is going through oxidation. Okay, it is going through oxidation. Why? You can see the increase of the oxidation number. So, few examples of oxidizing agents are chlorine, bromine. Why teacher write together? Because they are halogens. Potassium manganate 7 solution and potassium dichromate 6 solution. Okay, so teacher repeat, if you want to convert iron 2 ion to iron 3 ion, you need oxidizing agents. Okay, so you need oxidizing agents. So, example of oxidizing agents are chlorine, bromine, halogens, potassium manganate 7 and potassium dichromate 6 solution. Okay, so these are the popular oxidizing agents. Now, let's go to iron 3. If you want to convert iron 3 into iron 2, example of reducing agents, okay, are magnesium, zinc, these are popularly used, and hydrogen sulfide. Okay, so hydrogen sulfide, let me double check. So hydrogen sulfide, these are popular reducing agent. Okay, so reducing agent. So for your syllabus, we usually use a lot of magnesium and zinc. So please remember, in order for you to convert iron 3 ion to iron 2 ion, you need reducing agent. Okay, so let's go to, I hope you can understand the concepts. Okay, the concept introduction of who will be used as oxidizing reducing agent. Okay, so now we are going to look at few example of conversion of iron 2 ion to iron 3 ion. Okay, so let's go to, teacher have gone to first example, which is iron 2 sulfate. I hope you can read this. So this is iron 2 sulfate, that is literally involving iron 2 ion. So that is one clue. Okay, so iron 2 ion. Why? Because the molecular formula will give away the clue whether you are dealing with iron 2 ion or iron 3 ion. So since you are dealing with iron 2 ion, obviously you know that you are going through, your iron 2 ion is basically going to go through oxidation. Okay, so it is correct that teacher using bromine as an oxidizing agent. So let's look at the conversion, and we are going to discuss this subtopic in the form of redox reaction. Okay, now so let's go to iron 2 ion. So teacher told you already that iron 2 ion must be converted into iron 3 ion. There's no other way. So that is the reason why here those who goes through oxidation is iron 2 ion, and who goes through reduction is bromine water. Okay, now why you are telling that iron 2 ion goes through oxidation? Because donate electron and increase oxidation number. And here your bromine will receive. If you remember our part 9 video, you should know that halogens are supposed to receive electrons. Okay? Receive electron and reduce oxidation number. Okay, so you prove how it happens. Fe2 plus will donate 1 electron to become Fe3 plus. So can you see? Donate electron. Now let's go to bromine. Bromine will receive 2 electron to become 2 bromide ions. Okay, 2 bromide ions. Now let's look at the color. Okay, so you can find that, or before that, let's discuss regarding reduction, oxidizing agent and reducing agent. So who is the reducing agent here? So iron 2 ion is the reducing agent because it went through oxidation. Bromine is, can you see? Can you see? Oxidizing agent. Okay, so oxidizing agent, okay, which went through reduction. Now let's look at the difference. You can find the difference in color. Why? Because teacher already tell you brown color is for iron 3 ion, green color is for iron 2 ion. So you can find the solution change from green to brown. Okay, and for bromine, so remember that I told you that halogens are colored. Halogens have color, but halide, okay, halide, if you look at teacher's part 9 video, you'll find that halide, no color. So you can say that brown solution, even when you are dropping the bromine, you can find the brown turns into colorless. Okay, so this is the observation for this process. Okay, so you can say that indeed iron 2 ion has been changed into iron 3 ion. So let's go to overall ionic equation. Okay, so teacher write the overall ionic equation. Fe2 plus. Okay, but I have to balance this equation. If teacher want to balance this equation, I hope you can understand. Please watch my previous video. And you see, because I have to balance the two. Okay, so 2Fe2 plus bromine will produce 2Fe3 plus 2 bromide ion. Okay, so you can understand, I hope you can understand that the 2 electrons are literally cut in order to balance the equation. Ions left and electrons left and right. Okay, so this is the overall ionic equation for this reaction. Okay, so teacher also would like to give you another example for conversion of iron 2 ion to iron 3 ion. Why? Because teacher would like to explain to you how does the conversion of potassium manganate 7 happens. Okay, so you can find that potassium manganate 7 has a very distinctive purple color. Okay, and you can find that iron 2 sulfate is actually green solution. Okay, so now, so let's go to discussion on what happens when you are trying to convert iron 2 ion to iron 3 ion. Huh? Okay, now we start here. So, seperti biasa, Fe2 plus. How teacher managed to identify this is Fe2 plus is because, can you see the molecular formula? Iron 2 sulfate. So, iron 2 sulfate, the iron 2 ion is involved. So, let's go to redox reaction discussion. You can find that since I am looking at iron 2 ion has no other way to convert itself unless it's trying to convert into iron 3 ion. So that is the reason why you can find that iron 2 ion goes through oxidation in the solution and potassium manganate. Okay, so potassium manganate 7 is going through reduction. Okay, so now, so let's look at what happens again. Okay, so you will give an example. Donate electron, receive, sorry, donate electron, increase oxidation number, receive electron, reduce oxidation number. Okay, and you are going to prove to me. This is where I would like to explain nicely for you all. Huh? Okay, so this one should be no problem for you all. Okay, because teacher have explained here. Okay, donate electron to become iron 3 ion. But here teacher would like you to concentrate on the how to write the ionic equation, half ionic equation when you are dealing with potassium manganate. Okay, so what you are dealing with here is manganate 6. Okay, so we say that it is supposed to receive electrons. So now you don't know how many electrons you're going to receive. Okay, so just say, teacher right here. Okay, teacher right here. But you have ways. Teacher now going to teach you the technique. Okay, technique to balance or write down the proper half ionic equation for potassium manganate ion. Okay, so now why I am not writing potassium manganate, or you can even write here manganate ion. Manganate 7 ion goes through reduction, no problem. Okay, now here one thing teacher, first thing first, can you see how many oxygen is here? The moment you see 4 oxygen, you know that you are supposed to produce 4 water. Okay, and another thing, I want you to know that manganate ion, okay, manganate ion actually reduces from 7 plus to 2 plus. Okay, so you must know that manganate ion goes through reduction where it is reduced from 7 plus to 2 plus. Okay, so now my question is, if you are reducing 7 plus to 2 plus, how many electron do you think you need? Okay, from 7 to 2, that means you are supposed to involve 5 electrons, correct? You are supposed to involve 5 electrons. Okay, so since you are receiving electron, the electron must be received before the arrow. Okay, now number 2, clue number 2. Can you see you have 4 oxygen here? You are supposed to produce water using the half ionic equation for manganate ion. So that's the reason why teacher wrote here 4H2O. Okay, and you are producing Mn2 plus ion. Okay, so you are reproducing Mn2 plus ion, like what teacher said here. Okay, now you have to bring your hydrogen. That is the reason why we use acidified. Okay, acidified. Why? Because to bring hydrogen. Because since you have 4 times 2, you have 8 hydrogen ions involved. Okay, you have 8 hydrogen ion involved. Okay, allow me to repeat this. So I'll repeat this slowly. Please remember that when you are converting potassium manganate, sorry, when you are trying to convert iron 2 ion into iron 3 ion, you use a substance called Fe2 plus. Okay, so Fe2 plus has no other choice but to convert into Fe3 plus. Okay, now in order to do that, you are introducing potassium magnate, which is a purple color solution. So potassium magnate is an example of oxidizing agent. Potassium magnate 7 is an example of oxidizing agent. So oxidizing agent goes through reduction. Again, goes through reduction where the manganate, potassium manganate 7 change into manganate 2 ion, manganese 2 ion. Okay, 2 ion. So can you see that there's a reduction happening here? So bear that in mind when you are writing the half ionic equation. So MnO4 negative. Okay, so you should know how to find the oxidation number. MnO4 negative, and teacher already told you that it will change into Mn2 plus. So the rest will become water. Okay, so now next clue is you see how many water oxygen has it brought. It brought 4 oxygen, so you must have 4 water molecule. So you write a 4 water molecule as a product. So the product is just water and manganese 2 plus ion. Manganese 2 plus. Okay, now since you are telling that, we are telling that manganese 7 plus changes into manganese 2 plus, you are supposed to bring 5 electron. 7 reducing to 2, you need 5 electron, correct? So that is the reason why you add 5 electron. Now, where does the 8 hydrogen come from? Can you see here? In order to balance, that's why we use acidified potassium manganate 7. Okay, so can you see 8 hydrogen is used to produce 4 water molecules, because 4 times 8 is 4 times 2 is 8. So you bring 8 hydrogen ion. Okay. Now, so let's go to further observation. You will find, so in this case, you can find that iron 2 ion is reducing agent. Here is oxidizing agent. And you can find purple changing colors, and here you can find green changing into brown. Okay, so green changing into brown. So this is how you write down the um, uh, discussion regarding the redox reaction. When you are using example of oxidizing agent called acidified potassium manganate 7. Alright, okay class, let's continue on conversion of iron 3 ion to iron 2 ion. So this is relatively easy because usually, okay, hydrogen sulfide is not very popular, but the popular substance which are used usually is metals, which is magnesium and zinc metal. Okay, so now let's go to conversion. So I have FeCl3. Okay, iron 3 chloride, a substance called iron 3 chloride, and I put in a metal called magnesium. Okay, I put in a metal called magnesium. So let's see what happens to the substance. Okay, so usually, usually the metal put is actually in a form of powder. Okay, in a form of powder. Sorry for that. Okay, in a form of powder. So when you put the metal, you can see what happens. So let's discuss in the form of oxidation and reduction. Okay, oxidation and reduction. So what happens is you can find that iron 3 ion. So in iron 3 fluoride, you can find that it is consist of iron 3 ion. That is the clue for you. Okay, so you have no choice. That means you can find that iron 3 ion has no other choice but to convert itself to iron 2 ion. So that is the reason why you can say that who goes through reduction is iron 3 ion and magnesium goes through oxidation. Okay, so let me prove to you how magnesium goes through oxidation. Please remember that magnesium metals are supposed to donate electron. I hope you can remember this. Metals can never receive electron unless they are in ionic form. But since magnesium is an atom, magnesium has no choice but to donate electron. So magnesium donate electron to increase the oxidation number. Now let's look at iron. Okay, iron 3 ion receive electron and reduce its oxidation number. Okay, reduce its oxidation number. Let me prove to you how. Magnesium donates 2 electron to become magnesium ion. Iron 3 ion will receive 1 electron to become iron 2 ion. Okay, so in that case, you can say that magnesium is the reducing agent and iron 3 ion is the oxidizing agent. Okay, so iron 3 ion is the oxidizing agent. So please remember that. So let's go to half equation, or before that, let's write down the observation for this reaction. You will find that magnesium dissolves. Please remember that any metal which is changing into ion, any metal changing into ion always dissolves. Okay, and here you can find that from brown, the solution changes into green. Okay, so you can find that iron 2 ion has been produced. To further enhance your confirmation, okay, to further enhance your confirmation on the production of iron 2 ion and iron 3 ion, you can actually add a bit of sodium hydroxide. Okay, chapter 8 form 4 salt chapter, you can find that sodium hydroxide used in excess. Okay, sodium hydroxide used in excess, you will find that if iron 2 ion is present, dirty green precipitate is produced, and if sodium hydroxide, excess sodium hydroxide is used for iron 3 ion, you can find brown precipitate produced. Okay, so that is how you further confirm the existence of iron 2 ion in excess sodium hydroxide and brown, which is iron 3 ion in excess sodium hydroxide. Okay, so let's continue. So brown to green. Now teacher going to write down the overall ionic equation. Before that, please look that here your iron amount of electron for iron 3 iron is not balanced. So what teacher will do is I will add a 2 here. Hope you can remember teacher's previous video on how to balance ions. Okay, so now we write down the overall ionic equation. Okay, so magnesium plus 2 Fe3 plus will produce magnesium ion, because magnesium has gone through oxidation by increasing oxidation number. Can you see from 0 to 2 plus? Okay, and 2 Fe2 plus. Okay, so now, so 2 Fe2 plus. Okay, so now, so can you see that the electron has been cut? in order to balance the electron left and right. Okay, so this is what we call by overall ionic equation when it comes to this reaction. Okay, so my students, all of you, I hope all of you can understand, okay, on our concept of conversion of iron 2 ion and iron 3 ion. Okay, I hope to see you all in our next video, which is part 11 of redox reaction. Till then, take care. Thank you for watching teacher's video.